I'm Brooke from Intelligent Concrete, and I'm just going to discuss the C78 Flexural strength test for concrete beams with you. Just let you know why the test is important, the struggles that we face while taking the test or doing the test, and then what we find from it. So why C78 is important is it gives us the flexural strength of the beam in a PSI form, so that when we're using it for concrete runways for the airlines or for roads, it gives the engineers what they need to make that mix. All right, so some of the struggles that we face with the test. It's a large beam, so we're talking 20 inches by 6 inches, so it's heavy. We're looking at 65 plus pounds of weight when we're doing it. So after we cast the beam and then rip and strip it, we put it to cure in a lime water bath. It's very important that even once you rip and strip, you carry it this way so you're not allowing any flexural tension while it was freshly, after it was freshly molded to set in, causing fractures or any sort of strain on it. So first of all, carrying 65 pounds on end like this is, a challenge in its own. But then you have, when you're setting it into the lime water bath or taking it out, you have these cumbersome gloves that go up to your shoulders. You're in the tank trying to pull out these wet, extremely heavy beams, and again, carrying them so carefully so that you're not causing any of that stress on it. So once you take it out and it's on end, you wipe it down. Then you need to measure and mark it so that when you load it into the jig to perform the test, it's lined up appropriately. So the test that we're talking about here is using the 3-point loading system. So let's jump back here. With reference to its top side that it was molded with, you turn it on its side, you load it into the jig so that it's centered. You'll have 2 loading blocks up top, 2 on the bottom, causing a compressive strength on the top side of it and a tensile strength on the bottom. You then apply the load at a continuous rate between 125 to 175 psi until it breaks. And from there you can find the modulus of rupture by taking 3 measurements across the base as well as 3 measurements across the depth, averaging those, and then you use just a simple formula. It's PL over BD squared, which is the pounds, the max force in pounds, times the length divided by the average base times the average depth, that's squared, and that will give you the PSI of the modulus of rupture. So from there, that gives the engineers or whoever what they need to know as far as the modulus of rupture and the max PSI that this specific beam can hold. And again, from there, you can do a lot of different applications. So why we do this test, even though it's kind of a bear, it's extremely relevant. It shows so much information as long as it's handled correctly, done correctly, lined up. The ASTM goes through it step by step and is very particular and specific on how to load it, how to handle it, making sure it's centered and all of that, so that each time, regardless who's performing the test, you get the most accurate information so that it can be applied to real life situations. So yeah, I hope that helps. I also wanted to just mention too that formula that I said, that PL over BD squared, that's as long as it breaks within the middle 1/3 and then there's another one that is outside of the middle 1/3 as long as it's in 5%. That formula is 3P A over BD squared. So that is the pounds times the average to the tensile block. So it would be the nearest tensile loading point that you would measure that to, and then again divided by the average base times depth squared. So I hope that helps. If you have any questions, let us know. Again, it's a tough test, but it's so important, gives us great information. Yeah, thanks for watching.
Thanks for watching. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete. Beat asphalt.